Hey everyone, now we're going to take that end behavior chart that we just filled out in the previous video and apply it to our graph. As you can see on Delta Math, it's going to be multiple choice. You do not have to type anything in, you just have to select the correct end behavior sentence, I should say. So how you do this? First, you need to identify the end behavior of your graph. So on this graph, we can see both of our ends are going up. So if I bring back my end behavior chart, ends going up. So all we have to do is just find this sentence as our choices. Negative to positive, positive to positive. So let's look at our options. Negative to positive, positive to positive. There we go. It was the very first option listed for us. All right, our next one. We look at our ends, and we have going up and going down. So the left is going up and the right is going down. So again, we come back to our chart. Down here at the bottom, left is going up, right is going down. So we want negative to positive, positive to negative. So let's look at our options. Down here at the bottom, negative to positive, positive to negative. So it is this bottom choice. If you haven't guessed by now, the order that I have your table in is the order of your multiple choice answers. That's why I specifically did the table that way. All right. So now we're still talking about end behavior, but this time you do not get a graph. We're going to be looking at end behavior algebraically. So, end behavior of a polynomial describes what the ends of our graph will be doing. There's a specific way we will write end behavior given the leading degree and leading coefficient. This means we need to look at our leading term. And remember, our leading term is when it's in standard form. So we need to identify our leading term. So if it's not in standard form, make sure you know how to find your leading term when it's not in standard form. Now, what I mean by degree and leading coefficient is degree, is it even or odd? Leading coefficient, is it positive or negative? So, our degree, again, it's on the leading degree. So if we have an even leading degree and the leading coefficient is positive, the end behavior is going to be the exact same end behavior as if both ends were up. So it's going to be the exact same negative infinity to positive, positive infinity to positive infinity. So they are the same. Next, even degree, but now negative. We always start our x at negative infinity, but now this time it's going to negative infinity, and from infinity to negative infinity. So there's only two evens, one positive, one negative, meaning the last two are going to be our odds. So we have odd degree and positive. So that means, so x, it always stays the same. But now for over here, we're going to have negative infinity to negative infinity, and then positive infinity to positive infinity. And then finally, odd and negative leading coefficient, negative infinity to positive infinity, and then positive infinity to negative infinity. Just like with graphing, I do not expect you guys to memorize this chart. You can use this chart. You can use it as your notes. You do not need to memorize it. So now, let's take a look at some examples. Again, just like with graphing, Delta Math has these as multiple choice. So select the correct end behavior given the function. So remember, you have to ID your leading term. And remember, to do this, you just look for the highest exponent. So you don't have to put it in standard form. Just identify the term with the highest exponent. This first one, our highest exponent, 9x to the 5th. So, for degree, our degree is 5. So that means 5 is odd. Then, our leading coefficient is positive 9. So it is positive. So we want, from our chart, odd positive. We look here, odd positive. It's the third choice. Like I said, I have it in order. But just to double check, negative to negative, positive to positive, negative to negative, positive. Whoops, that's negative. Negative to negative, positive to positive. So actually, it's not quite in order. So actually, they change it up on you. So just be careful. Make sure you go through your options, because they shuffle them. I didn't realize they shuffle them. All right, our next one. So identify the highest exponent leading term. Right here, negative 2x to the 4th. So our degree is 4. Meaning our degree is even, and our leading coefficient is negative 2, so it is negative. So even negative, so negative negative, positive negative. So let's look for that. Negative negative, positive positive, nope. Negative negative, positive negative. There we have it. It is this option right here. And there we go, end behavior algebraically. Hang in there. We have one more page of notes, and then we're done with semester 1.